Welcome to our YouTube channel Experience Tutor. Today we'll discuss Class 9 Science Chapter 11 Work and Energy Part 3. And here is our welcome message. Before we begin, please subscribe, like and share our channel among your friends and relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded. Let us begin the lesson. So the problem is an object of mass 15 kg is moving with uniform velocity of 4 meter per second. What is the kinetic energy possessed by it? So solution is simple. Let us see. Mass of the object is equal to 15 kg. Velocity of the object is equal to 4 meter per second. Ek is equal to kinetic energy is equal to half mv square. Therefore, we can write it as half mass is 15 multiplied by velocity square, that means 4 into 4. Here we can cancel 2 1 ja 2, 2 2 ja 4. Therefore, we can write it as 120 joule. The kinetic energy is 120 joule. So the final line we can write the kinetic energy is 120 joule. Now we'll study about potential energy. So what is potential energy? The energy of a body, the definition is the energy of a body due to its position or change in shape is known as potential energy. As potential energy. Example of potential energy: There are many examples. For example, water kept in dam is one of the example of potential energy. It can rotate turbine to generate electricity due to the position due to its position above the ground. Wound up spring on a toy car. It possesses potential energy which is released during the individual unwinding of spring so car can move. Bent screen of bow. Potential energy is due to the change in shape deformation released in the form of kinetic energy. While shooting an arrow. Factors affecting potential energy. So now factors. First factor which affects potential energy is mass. So potential energy is directly proportional to the mass. Second factor which influences potential energy is height. Potential energy is directly proportional to the height. That means greater the height from the ground, greater is the potential energy. Similarly, greater the mass of the body, mass of the object, greater the potential energy. So we can write for the we will derive a calculation for potential energy. Potential energy of an object on a height so we'll find the derivation for this. So if a body if a body of mass m is raised to a height h above the surface of the earth, the gravitational pull of the earth is in the is acting in the downward direction. To lift the body, we have to do a work against the force of gravity. Therefore, we can write work done W is equal to force into displacement where force we can write as mg and displacement can be written as h. Therefore, work done is equal to mgh. This work done is stored in a body in the form of potential energy. Therefore, potential energy for this case is m into g into h. So now let us see a problem based on potential energy. If a body of mass 10 kg raised to a height of, so height is given, mass is given, height of 6 meter above the earth, calculate the potential energy. So solution, first of all we'll write all the given things. Mass of the body is equal to 10 kg. Height of above the earth, so it can also be written as mass m. Height above earth is equal to 6 meter. Acceleration due to gravity is equal to 10 meter. This is again denoted by h, height. Acceleration due to gravity is denoted by g, 10 meter per second square. Now potential energy EP is equal to m multiplied by g multiplied by h. Put all the values, all the given value, 10 kg into 10 meter per second square into 6, that is 600 joule. The potential energy of the body is, so we write it, the potential energy of the body is 600 joule, and this is the answer. Now we'll study about transformation of energy. So transformation of energy. So, transformation of energy. The change of one form of energy to another form of energy is known as transformation of energy. The change of one the change of one form of energy to another form is known as transformation of energy. Is known as transformation transformation of energy. For example, a stone on a certain height has entire potential energy, but when it starts moving downward, potential energy of the stone goes on decreasing as the height goes on decreasing, but kinetic energy goes on the opposite direction, goes on increasing as velocity of stone goes increasing. At the time stone reaches ground, potential energy becomes zero and kinetic energy is maximum. Thus, its entire potential energy is transformed into kinetic energy. At geoelectrical powerhouse, the potential energy of water transformed into kinetic energy and then into electrical energy. So, similarly, plants use solar energy to make chemical energy in the food by processing photosynthesis. Law of conservation of energy. So, now we'll study law of conservation of energy. First, energy can neither be created nor destroyed. First law. Secondly, whenever energy changes from one form to another form, the total amount of energy remains constant. So this is all about law of conservation of energy. Now we'll study about conservation of energy during free fall of a body. So a ball of mass m at a height h has potential energy is equal to mgh. As the ball falls downward, downwards, height h decreases. So the potential energy also decreases. Kinetic energy at h is 0. Is 0, but it increases during falling of a ball. So we can write the sum of potential and kinetic energy of the ball remains same at every point during its fall. So the sum of potential energy and kinetic energy of the ball remains the same at every point during its fall. Fall. So potential energy plus kinetic energy is equal to constant. So potential energy we can write mgh, kinetic energy we can write half mv square is equal to constant. Now this is all about energy. Now we'll start power. What is power? Rate of doing work is called power. Also, it can be, or we can write it as power is defined as the rate of energy consumption. So power can be written as work done upon time taken, rate, so time taken, rate of doing work, which implies that we can write power as W upon T. Next, unit of power. SI unit of power is watt. SI unit of power is watt or W, 1 joule per second. So 1 watt is equal to 1 joule upon 1 second, or we can write it as 1 W is equal to 1 J upon 1 S. How will we define 1 out? What? So power is 1 watt. Watt. When 1 joule work is done, work is done in 1 second. In 1 second. Average power. Power is equal to total work done or total energy used upon total time taken. Now, power of electric gadget. The power of electrical appliances tells you the rate of electric energy is consumed by it. So, bigger power of unit, bigger powerful unit are kilowatt. 1 kilowatt is equal to 1000 watt. So, bigger unit of power is 1 kilowatt, that is kW, which is equal to 1000 watts, which can be also written as 1000 joule per second. And this is the unit end of today's unit. In the next class, we'll do the next rest of the lesson. So before we finish, we have a humble request to you. Please subscribe, like, and share our channel among your friends and relatives. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification. Thank you for your support. Thank you very much.